Hello to everyone. In this session, we are going to find how to find the eigenvalues and eigenvectors of the matrix. In this topic, there are 4 types. Type 1, non-symmetric matrices with non-repeated eigenvalue. First problem, find the eigenvalues and eigenvectors of the matrix is a 3 by 3 matrix 1, 0, minus 1, 1, 2, 1, 2, 2, 3. First step, we should identify the given matrix is symmetric or non-symmetric. If it is symmetric means it should satisfy the condition Aij equal to Aji. If it is not satisfies means the given matrix is non-symmetric. Now here your main diagonal elements are 1, 2, 3. Symmetric means these two terms and this terms and these two terms must be same. So here it is not equal, so the given matrix is non-symmetric. Solution, there are 3 steps. First step, find the characteristic equation. Step 2, to solve the characteristic equation, that is to find the eigenvalues. Step 3, find the eigenvectors. First, step 1, find the characteristic equation. So given matrix is 3 by 3. So formula method is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Already we know that S1, S2, S3 abbreviation. S1 is sum of the main diagonal elements, S2 is sum of minor of the main diagonal elements, S3 is determinant of the given matrix. Now S1, sum of main diagonal elements, that is 1 plus 2 plus 3, so it is 6. S2, sum of minor of the main diagonal elements, first main diagonal element 1. So the minor are 2, 1, 2, 3 plus second main diagonal elements 2. So the minor elements are 1, minus 1, 2, 3. The last main diagonal, that is 3. So the minor elements are 1, 0, 1, 2. So this is nothing but 2 by 2 determinant. I hope everyone know how to expand 2 by 2 determinant. First multiply from up to down, then down to up. Whenever we are multiply from down to up, we should include opposite sign, that is plus means minus, minus means plus. So if you are expanding means the final answer is S2 equal to 11. Next, S3. S3 is determinant of the given matrix. So first let us assume given matrix is A. So S3 equal to determinant of A. So I hope everyone know how to expand determinant of A, that is 3 by 3 matrix 1, 0, minus 1, 1, 2, 1, 2, 2, 3. First fix the symbol plus, minus, plus. So now we are going to convert 3 by 3 determinant to 2 by 2. So first term 1. So minor elements are 2, 1, 2, 3. Now your second element sign minus, here plus, minus into plus, minus. So here minus 0 into, the elements are 1, omit the corresponding rows and corresponding columns, that is 1, 1, 2, 3. Now the last element plus into minus, minus 1, omit the corresponding rows, corresponding columns. So the elements are 1, 2, 2, 2. So now this is 2 by 2 determinant. So as usual, up to down, then down to up, the final answer is 6. S3 equal to 6. Sub these values into your formula, it is lambda cube minus S1 lambda square plus S2 lambda minus S3. So the characteristic equation is lambda cube minus S1 value 6. So 6 lambda square plus S2. S2 value is 11. So plus 11 lambda. Next last one S3. S3 also 6. So minus 6 equal to 0. That is step 1. Now step 2, to solve this characteristic equation, that is to find the eigenvalues. Step 2, find the eigenvalues. So the characteristic equation is lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0. Now we are going to solve this equation. So this is nothing but cubic equation. By synthetic division we can convert cubic to quadratic. So now by synthetic division we get, has to write the coefficient of the variables. So here coefficient is 1, next coefficient lambda cube means next lambda square coefficient minus 6, next coefficient 11, next last one constant minus 6. Suppose your equation is lambda cube plus 11 lambda minus 6 means here you should include 0. It means it shows that 0 lambda square. Clear? So here your equation is minus 6 lambda square. Suppose lambda is missing means 1 minus 6, next coefficient of lambda is 0, then last step. So here 1 0, sorry it is not 0, here minus 6, 1 minus 6 11 minus 6. So we have to verify by 1, next minus 1, next 2, then minus 2, then continue the same procedure. For all the problems here default 0. So these two terms adding, these two terms multiplication. So 1 plus 0 1, 1 1 are 1, adding minus 6 plus 1 this becomes minus 5, these two terms multiplication. So 1 into minus 5 minus 5, 11 minus 5 becomes 6, 1 6 are 6. So minus 6 plus 6, so 0. So the first eigenvalue lambda equal to 1. Until 0 we have to continue the procedure. Until you have get the 0 we have to continue the procedure. Suppose here if it is not 0 means next we have to try by minus 1, next to 2, next to minus 2 until get 0. So your first eigenvalue lambda equal to 1. So 3 by 3 matrices means minimum 3 eigenvalues, 2 by 2 matrices means 2 eigenvalues, 4 by 4 matrices means the given matrix having 4 eigenvalues. Now first eigenvalue lambda equal to 1. So next we have to find the remaining 2 eigenvalues. Now cubic equation becomes quadratic. So here first lambda cube, here the first system start by lambda square. So the quadratic equation is lambda square first term, next one minus 5 minus 5 lambda, next term 6 plus 6 equal to 0. So here last two terms multiplication, here lambda square coefficient is 1, so last two terms multiplication 6, middle term minus 5. The addition of two numbers would be minus 5, the product of the two numbers should be 6, so we have to identify the numbers. So minus 5 means minus 2 minus 3, if we are adding means it becomes minus 5, then product of the numbers would be 6, minus into minus plus 2 3s are 6. So if these two numbers satisfy the conditions, therefore the eigenvalue, so we can directly write lambda equal to, because here equal to 0, so minus 2 goes to other side becomes plus, so lambda equal to 2, next one lambda equal to 3. Simple, just change the sign. If it is plus means minus, minus means plus. Suppose here plus 2 means lambda equal to minus 2. Suppose here plus 3 means lambda equal to minus 3. So here your eigenvalue, the remaining eigenvalues are 2 and 3. Therefore the eigenvalues are 1 first eigenvalue, second one 2, third one 3. Step 2. Now step 3, find the eigenvectors. Step 3, find the eigenvectors. Now step 3, find the eigenvectors, that is using this formula A minus lambda I into capital X equal to 0. A is given matrix, lambda is eigenvalue, I is unit matrix, X is nothing but given matrix coefficients, that is coefficients means variables here. So now given matrix 1 0 minus 1 1 2 1 2 2 3 minus lambda into identity matrix, X is given elements, that is x1 x2 x3 variables equal to 0. Now subtract the corresponding elements, multiply lambda inside the bracket. So here lambda, here also lambda, here also lambda. So subtraction means 1 minus lambda. So 0 minus 1. So 1 here, 2 minus lambda 1, 2 2 here 3 minus lambda into x1 x2 x3 equal to 0 0 0. So this is nothing but equation number 1. Now case 1. So you have 3 eigenvalues. Now case 1, the first eigenvector. So first eigenvalue lambda equal to 1. So put lambda equal to 1 in equation 1. So put lambda equal to 1. 1 minus 1 0, 0 0 minus 1. Here lambda equal to 1, 2 minus 1 1. So 1 1 1. Here lambda equal to 1, 3 minus 1 2. So 2 2 2 into x1 x2 x3 equal to 0. Now matrix multiplication, first row first column, second row first column, third row first column, multiply means 0x1, this is 0x1 plus 0x2 minus x3 equal to 0. Next one, x1 plus x2 plus x3 equal to 0. Last one, 2x1 plus 2x2 plus 2x3 equal to 0. Out of these 3 equations, you have to take any 2 equations, but the condition is it should not be same. You have to choose any 2 different equations. So here from this step itself you can identify. See, the first one 0 0 minus 1, the second one 1 1 1. What about the last one 2 2 2? You can divide by 2 means it becomes 1 1 1. So 2 and 3 are similar. So you can't take 2 and 3. So the possibilities are 1 and 2 possible and 1 and 3 possible. We can't take 2 and 3. So now I am taking 1 and 2 or 1 and 3. So now I am taking 1 and 2, these 2. x1, x2, x3. Now I tell you how to find eigenvector for lambda equal to 1. That is case 1. x1, x2, x3. Here start by 1 means so 2, next number 2, 3, 1, 2. It means you have to write coefficient of x2, x3, x1, x2. So you are taking equation 1 and 2. Here coefficient of x2 is 0. Next 3. Coefficient of x3 is minus 1. Next 1. Coefficient of x1 is 0. Next coefficient of x2 is again 0. Second equation, the same procedure, coefficient of x2. So 1, 1. Next it becomes here 1. This is also 1. Please rub this. This is for our identification. Now apply rule of cross multiplication. So x1 divided by that's all. There is rule of cross multiplication. This is nothing but like 2 by 2 determinant. Up to down, then down to up. Whenever you are multiplying from down to up, just include opposite sign. That is plus means minus. So 0 into 1, 0. 1 into minus 1, minus 1. So opposite sign plus 1 equal to x2 divided by minus 1 into 1. That is minus 1. 1 into 0, 0. That's all. x3. Because this is x1, x2, x3 pair. So x3 0 into 1, 0. 1 into 0, that is also 0. So therefore the final answer is x1 divided by 1 x2 divided by minus 1, x3 divided by 0. Therefore, the first eigenvector capital X1 equal to first one 1 minus 1 0. So, this is our first eigenvector for our first eigenvalue, that is lambda equal to 1. So, this is our main equation, equation number 1. So, now case 2, the same procedure, put lambda equal, second eigenvalue is 2. So, put lambda equal to 2. Thus, we have to follow the same procedure. Next, put lambda equal to 3. The same procedure. The condition is we are not supposed to choose similar equation. We have to choose any two different equations. Suppose here 2 and 3 are same. So, we are not supposed to take 2 and 3. So, now, suppose all the equations are different, means you could take any two. That is, the possibilities are 1 and 2 or 1 and 3 or 2 and 3. So, similarly, we can find the eigenvectors for remaining two eigenvalues, that is lambda equal to 2 and lambda equal to 3. So, case 2, your second eigenvalue is lambda equal to 2. So, put lambda equal to 2 in the same equation number 1. So, here put lambda equal to 1, apply the same procedure whatever we are followed in your case 1. The second eigenvector is x2 equal to 2 minus 1 minus 2. Next, case 3, put lambda equal to 3 in equation 1. Case 3, in equation 1, apply the same procedure. Your third eigenvector is x3 equal to 1 minus 1 minus 2. So, now type 2, problems based on non-symmetric matrices with repeated eigenvalues. Your type 1 is non-repeated eigenvalues, but here repeated. The first problem, find the eigenvalues and eigenvectors of the matrix. So, 3 by 3 matrix. 3 by 3 matrix means 3 eigenvalues and 3 eigenvectors. Here our matrix are minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Solution, the same 3 steps. First step, find the characteristic equation. Step 2, solve the characteristic equation, that is find the eigenvalues. Last step, find the eigenvectors. Now, step 1, find the characteristic equation by formula method, lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. S1, S2, S3. We know that how to find S1, S2, S3. S1 is sum of main diagonal elements, that is minus 2 plus 1, 0. So, answer is minus 1. S2 is sum of minor of the main diagonal elements. So, first minor means minus 2 means 1, minus 6, minus 2, 0. Minus 6, minus 2, 0. Second one, for second main diagonal is 1. So, minus 2, minus 3, minus 1, 0. Last one 0. So, minus 2, 2, 2, 1. If we are expanding means the answer is minus 21. Now, last one S3. S3 is nothing but determinant of the given matrix. Let us assume the given matrix is A. So, 3 by 3 determinant, the answer is 45. Now, sub these values into your formula. So, lambda cube minus S1 is minus 1, minus into minus plus, plus lambda square plus S2. S2 answer is minus 21, plus into minus, minus. So, minus 21 lambda minus S3. S3 answer is 45. So, minus 45 equal to 0. Now, step 2, find the eigen values. So, given lambda cube plus lambda square minus 21 lambda minus 45 equals 0. By synthetic division method, we get 1, 1, minus 21, minus 45. So we had to check by 1 minus 1, next 2 minus 2, next 3 minus 3. So this equation is satisfied by minus 3. First number default 0, so adding means 1, multiplication minus 3, it becomes minus 2, multiplication it becomes 6, so it becomes minus 15, so multiplication means becomes 45, so it becomes 0. So first eigenvalue is lambda equal to minus 3. Now we have to find the remaining 2 eigenvalues by quadratic method. That is last 2 terms multiplication, middle term addition means remaining eigenvalues are minus 3 and 5. Very simple concept, that is this is nothing but lambda square minus 2 lambda minus 15 equal to 0. Last 2 terms multiplication, middle term addition, that is last 2 terms multiplication minus 15, middle term addition minus 2. So numbers are, suppose minus 5 minus means becomes minus 8. So minus 5 plus 3. If we are adding means it becomes minus 2. If we are multiplying means it becomes minus 15. Therefore the direct answer is, I already told you, just put the opposite sign. If it is plus means minus, minus means plus. So here plus 3, that's here I wrote minus 3. So here minus 5, here plus 5. Therefore the eigenvalues are lambda equal to minus 3, 5. Here 2 eigenvalues are repeated. The first problem eigenvalues are 1, 2, 3 non-repeated. Here our eigenvalues are minus 3, 5. 2 eigenvalues are repeated. Step 3, find the eigenvectors. Using the formula a minus lambda I into x equal to 0. Already we know that A is given matrix, lambda is the eigenvalue, I is unit matrix, x is the given elements, variables. So A given minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0, minus lambda into I. I is unit matrix, it is a 3 by 3 matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1 into x. So the variables are x1, that's all. Now multiply lambda inside the bracket and then subtract. So first one minus 2 multiply lambda inside the bracket. So it's having only your main diagonals. So minus 2 minus lambda. So next one 2 minus 3. Second row 2 1 minus lambda minus 6. Now last one minus 1 minus 2 0 minus lambda into x1, x2, x3 equal to 0, 0, 0. That is equation number 1. Now case 1. Put lambda equal to minus 3 in equation number 1. So first eigenvalue is lambda equal to minus 3. Second eigenvalue also lambda equal to minus 3. Last eigenvalue is lambda equal to 5. Now lambda equal to minus 3. Put lambda equal to minus 3 in equation number 1. So here lambda equal to minus 3. Minus into minus plus. So minus 2 plus 3 it becomes 1. The remaining second one 2 minus 3. Now second term here 2. So here 1 minus lambda. Lambda value is minus 3. So minus into minus plus. So 1 plus 3 it becomes 4. The last one minus 6. Now third row minus 1, minus 2, 0 minus lambda. Lambda value equal to minus 3, minus into minus plus. So that is 0 plus 3, 3, x1, x2, x3. Hereafter apply rule of cross multiplication. Already explained you. So we have to take any two different equations. Okay, here your first equation is 1, 2 minus 3. Second 2, 4 minus 6. If you are dividing by 2 means it becomes 1, 2 minus 3. So 1 and 2 same. The last one minus 1, minus 2, 3. If you are multiplying by minus means it becomes 1, 2 minus 3. Here all the equations are same. So we need minimum 2 equations. Here all the equations are same. So the procedure is put. So the equation is, first I tell you, write the equations. First one x1 plus 2x2 minus 3x3 equal to 0. So I am choosing the first equation. Okay. Now the procedure is put x1 equal to 0 in this equation. So put x1 equal to 0 means, so equation becomes, above equation becomes 2x2 minus 3x3 equal to 0, 2x2 equal to 3x3, x2 divided by 3 equal to x3 divided by 2. Therefore, the first eigenvector x1 equal to, so x1 equal to 0, first one 0, x2 answer is 3, x3 answer is 2. That's all. This is the first eigenvector. Now, your second eigenvector. Your second eigenvalue is lambda equal to minus 3. So the same equation. So next one, put x2 equal to 0 in this equation. So put x2 equal to 0 means the equation becomes x1 minus 3x3 equal to 0. So x1 equal to 3x3. So x1 divided by 3 equal to x3 divided by 1. So the second eigenvector is 3. x1 element is 3, x2 is 0, x3 is 1. So this is the second eigenvector. Now we are going to find the third eigenvector. Third eigenvector is 5. That is different. Suppose your third eigenvector also minus 3. Suppose minus 3, minus 3, minus 3. So first two eigenvectors we know how to find. So third eigenvector. So for third eigenvalue is minus 3. So put x3 equal to 0. Put x3 equal to 0 means x1 plus 2x2 equal to 0 plus 2x2 goes to other side minus 2x2. So x1 divided by minus 2, x2 divided by 1. So but here your third eigenvalue is 5. So we will see how to find third eigenvector. Case 3. We are going to find third eigenvector. So the third eigenvalue is lambda equal to 5. Put lambda equal to 5 in equation number 1. So put lambda equal to 5 means, so minus 2 minus 5. So answer minus 7. So second one 2, then minus 3. Here 2, 1 minus lambda. So 1 minus 5 becomes minus 4. Next one minus 6. The last row minus 1, minus 2, 0 minus lambda, that is minus 5 into x1, x2, x3 equal to 0, 0, 0. So just look at here, all the equations are different. Minus 7, 2, minus 3, 2, minus 4, minus 6, 1, minus 2, minus 5. Suppose if you are dividing the second equation by 2 means it becomes 1, 2, 3, but here the last number is 5. So all are different. So already we know that by rule of cross multiplication we have to choose any two different equations. Here you can take 1 and 2, the possibilities are 1 and 2 or 1 and 3 or 2 and 3. So already we are derived how to find eigenvectors for by applying rule of cross multiplication. So the third eigenvector is 1, 2, minus 1 by rule of cross multiplication. Type 3 problems based on symmetric matrices with repeated eigenvalues. So, type 1 and 2 are non-symmetric, type 3 symmetric with repeated eigenvalues. The first problem, find the eigenvalues and eigenvectors of the matrix. So, 3 by 3, 0, 1, 1, 1, 0, 1, 1, 1, 0. Solution, the same 3 steps. Step 1, find the characteristic equation. So, by formula method, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Step 1, that is find the characteristic equation. S1 is S1, S2, S3, we know that how to find. S1 is sum of the main diagonal elements, here our main diagonal elements are all 0. So, S1 answer is 0. S2, sum of minor of the main diagonal, the first main diagonal elements 0. So, the minor elements are 0, 1, 1, 0 plus second main diagonal 0. So, omit the corresponding rows, corresponding columns. So, 0, 1, 1, 0, the last one 0, omit the corresponding rows, corresponding columns. So, plus 0, 1, 1, 0. So, this is 2 by 2 determinant. I hope everyone know how to expand. First multiply from up to down, then down to up, 0 into 0, 0, 1 ones are minus 1. Whenever we are multiplying from down to up, we should include opposite sign, that is plus means minus, minus means plus. 0, so minus 1, 0, so plus 1 it becomes minus 1. So, answer is minus 3. Now, the last one, S3. S3 is determinant of A. So, 3 by 3 determinant. So, you should convert first from 3 by 3 to 2 by 2. So, the answer is 2. Sub these values into your formula. So, characteristic equation becomes this one, lambda cube minus S1 answer is 0, 0 lambda square, S2 is minus 3. So, minus 3 lambda, S2 value is 2, minus 2 equal to 0, because here sign is minus. So, this is characteristic equation. Now, step 2, find the eigenvalues, that is to solve the characteristic equation by synthetic division. We get coefficient of lambda cube 1, coefficient of lambda square 0, next minus 3, 2. First I am going to verify by 1. So, 0, 1, multiplication 1, adding 1, one answer 1, so minus 2, multiplication minus 2, this becomes minus 4. So, it is wrong. So, next I am going to check by minus 1. So, 1 in plus 0, 1, 1 into minus 1, adding minus 1, multiplication 1, adding minus 2, multiplication 2, that is right, satisfied. So, first eigenvalue is lambda equal to minus 1. So, now cubic becomes quadratic equation is lambda square minus lambda minus 2 equal to 0. So, last two terms multiplication and middle term addition. So, numbers are 1 into minus 2, middle term is minus 1. So, the multiplication of two numbers should be minus 1, the multiplication of two numbers should be minus 2, addition of two numbers should be minus 1. So, the numbers are minus 1 plus 2, minus 1 plus 2 becomes minus 1, no it is wrong, change the sign. So, minus 2 plus 1, so minus 2 plus 1, minus 1, multiplication minus into plus minus 2 ones are 2. So, therefore, the answer is lambda equal to 2 and lambda equal to minus 1, opposite sign. Therefore, the eigenvalues are lambda equal to first eigenvalue minus 1, second eigenvalue minus 1, third eigenvalue 2. Here 2 eigenvalues are repeated. As the given matrix is symmetric. Symmetric means it should satisfy the condition Aij equal to Aj. There is 2, these values should be same, these 2 values should be same, and these 2 values should be same. Next we are going to find eigenvectors for this eigenvalues. Step 3, find the eigenvectors using this formula, that is A minus lambda I into x equal to 0. A is your given matrix, that is 0, 1, 1, 1, 0, 1, 1, 1, 0. A minus lambda I is unit matrix, is a 3 by 3. Into x, x is nothing but variables, x1, x2, x3 equal to 0. Multiply lambda inside the bracket, then subtract. So the first one 0 minus lambda, second element is 1 1, next 1 0 minus lambda, 1 1 1 0 minus lambda into x1 x2 x3 equal to 0. This is equation number 1. Now I am going to find your first eigenvector. So first eigenvalue is lambda equal to minus 1. The first 2 eigenvalues are repeated, that is minus 1 minus 1. Put lambda equal to minus 1 in equation 1. So put lambda equal to minus 1 means minus into minus plus. So first row becomes 1 1 1. Second also same 1 1 1. Third also same 1 1 1 into x1 x2 x3 equal to 0 0 0. Here all the equations are same. So we know how to find the eigenvector. So we have all the equations there. I am taking the first equations, that is x1 plus x2 plus x3 equal to 0. So we know how to find eigenvector. If eigenvalues are repeated means put x1 equal to 0. So put x1 equal to 0. So in the above equation, so it becomes x2 plus x3 equal to 0, x2 equal to minus x3, therefore x2 divided by minus 1 equal to x3 divided by 1. So first eigenvector is 0 minus 1 1 or 0 1 minus 1. This is also possible. Now the second eigenvector. The second eigenvalue is lambda equal to minus 1. Suppose the given matrix is non-symmetric. Non-symmetric means the procedure is put x2 equal to 0, but the here given matrix is symmetric. So we are not supposed to put x2 equal to 0. Now we are going to find the second eigenvector. The second eigenvector, put lambda equal to, what about the second eigenvalue, that is minus 1 minus 1 2. Now I am taking lambda equal to 2. Put lambda equal to 2 in equation number 1. So here 0 minus 2. So minus 2 1 1 1 minus 2 1 1 1 minus 2 into x1 x2 x3 equal to 0 0 0. Here all the equations are different. See, minus 2 1 1 1 minus 2 1 1 1 minus 2. So our concept is by rule of cross multiplication we have to take any two different equations. Here you can take 1 and 2 or 1 and 3 or 2 and 3. All the possibilities are there. 1 2 1 3 2 3. So by rule of cross multiplication the second eigenvector is 1 1 1. Now first eigenvector answer is x1 is 0 minus 1 1. Second eigenvector is 1 1 1. Now we need third eigenvector. the procedure for third eigenvector to find third eigenvector is using these two eigenvectors to find the third eigenvector, that is x3 is nothing but using these two eigenvectors. So, first eigenvector is 0, minus 1, 1. So, 0 x1 minus x2 plus x3 equal to 0. This is case 2, this is case 3. 0 x1 minus x2 plus x3 equal to 0. Second one, x1 plus x2 plus x3 equal to 0. So, here we have two equations. Two equations are different. Again, by rule of cross multiplication, x1, x1, x2, x3. The cross multiplication rule is first here 2, 3, 1, 2. So, 2, 3. 2 coefficients minus 1, 3, 1, next 1. 1 is 0, next 2. 2 is minus 1. Next second equation 2. 2 is 1, 3, 1, next to 1, 1, 2, 1. Just rub this. Now apply rule of cross multiplication, that is up to down, down to up to down, down to up to down, down to up. So, multiplication means x1 divided by x2 divided by x3 divided by. So, 1 into minus 1 into 1 minus 1, second multiplication minus 1. Clear? 1 answer 1, 1 into 0, 0, 0 into 1, 0, 1 into minus 1 becomes plus 1. So, answer x1 divided by minus 2, x2 divided by 1, x3 divided by 1. Therefore, the third eigenvector is minus 2, 1, 1.